Hi, I'm Chris from 99scloud.com. In this video I'll give you an introduction to Amazon DynamoDB. As this is an introduction, I'll not be showing any practical examples, but such tutorials are planned to come soon. So feel free to subscribe and hit the bell button if you want to be notified once they are available. In order to get an understanding of what DynamoDB is, we'll go over the differences between relational databases, NoSQL key value store databases and document store databases. We'll figure out the pros and cons between relational and NoSQL databases and when one or the other is better suited for your projects. Then we'll dive deeper into the features of Amazon DynamoDB and how to structure and query the data. So if you are interested, stay tuned. Hey and welcome back. If you prefer written tutorials, feel free to check out my website 99scloud.com. The link is in the comment section below this video. And if the content provides value to you, please give it a like and consider subscribing if you want to see more videos like this. So without further ado, let's have a look at what DynamoDB is. DynamoDB is Amazon's version of a NoSQL database to run high-performance applications at any scale. Like other NoSQL databases, it uses the design of a key value store and offers several high-end features such as security and encryption, backups, multi-region replication, in-memory caching, and more. Amazon DynamoDB is a managed and serverless service, which means you don't need to deal with the underlying infrastructure such as the servers. Amazon will do all of that for you behind the scenes. So the only thing you need to do is to add the required tables and organize the data. Before we dive into DynamoDB, I would like to give a short introduction to the conceptual differences between NoSQL and relational databases. This will give you a better understanding of how DynamoDB operates, what you can do with it, and what you can't do with it. So let's have a look at how relational databases work at a glance. A relational database organizes data into tables with columns, which contains the attributes, and rows that contain the data records. Each row has a unique key called primary key to identify it. The tables are structured into entities such as products, for example, if you have a list of products. Let's take a look at how such a table would be structured in a relational database. In the products table, the first attribute will be the primary key. The primary key is unique and identifies the record. Additionally, we have a name, price, and memory attribute. In a relational database, the attributes have a data type such as varchar, integer, decimal, float, text, or blob. In our example, the name would be defined as a varchar, which is a fixed amount of characters. The price would be defined as a decimal or float value, which supports fractional digits. And the memory would be defined as an integer, so a full number without fractional digits. By defining data types for the attributes, the database can optimize them to retrieve them faster than if they would be stored as text. Additionally, the data size will also be kept smaller as the values use less space. Because we specify data types, we can use the SQL language not only to read and write data, but we can also do calculations with float, decimal, and integer values, which can be more efficient than doing the calculations on the client side. So What are some of the advantages of using a relational database? Well, it is possible to filter by each column without having to create indexes. And it is possible to reference data between tables using foreign keys. This gives you a lot of flexibility to structure your data and enables you to do queries over several tables using the references. Let's look at an example. Let's say you have a bunch of customers and each customer can have one or more addresses. So you decide to create two tables based on the entities. One table will be called customers and the other will be called addresses. Let's assume that you want to get a list of all addresses, which should also include the customer name. In the customers table, you'll define a primary key called ID, which identifies each customer record and name attribute. In the addresses table, you'll define a primary key called ID, which identifies the record, an address attribute that will contain the full address, and a foreign key attribute with the customer ID. Through the foreign key attribute, we know which address belongs to which customer. With the tables created, you can now construct the SQL query. The query can be broken down into a few parts. In the first part, after the select statement, you will define what kind of fields you want to get from the query and how the fields should be called. So here you specify that you want to get the ID value from the addresses table and list it as an attribute called address ID. Then you'll get the address value from the addresses table and list it as an attribute called address. And then you'll get the name from the customers table and list it as an attribute called customer name. In the second part, after the from statement, you will define from which tables you want to get the data. In this example, it will be the customers table and the addresses table. And in the third part, after the where statement, you can specify filters and relationships. In this example, you specify that you want to have the customer record joined to each address through the foreign key called customer ID in the addresses table. The output of the query would look as followed, and as you can see, the output is now structured in three attributes: the address ID, which is the primary key, the address itself, and the customer name. With this, you have conducted a query over two tables, where you got the address ID and the address from the addresses table, and the customer name from the customers table. If you wanted, you could now do queries over even more tables. As long as you can identify the relationships to the records through foreign keys, you can keep adding tables. So what are the advantages of using a relational database? Well, one advantage is that you can define the tables and relationships and decide later what data you want to query. So you don't need to know the query patterns up front. And another advantage is that you can narrow down your searches by filtering by each individual attribute, as the table has a fixed schema. And the third advantage is that calculations can be done directly in SQL, so that only the result is sent back to the application. But there are also some disadvantages when using a relational database. One disadvantage is that the query speed will decrease based on the amount of data and complexity of the query. And another disadvantage is that because of the relationships, each replicated database needs to have the full set of the data. Think about what would happen if your query would have to fetch data from different servers in the network, each having some network latency. The data could not be returned within a reasonable time. This makes it more difficult to distribute and scale the database and can lead to availability and scaling problems. So now that we have a good understanding of what a relational database is and works, let's go into the concepts of NoSQL databases. At a glance, NoSQL databases can work very differently, as the term NoSQL doesn't describe how the database works, just that it is different from a traditional relational database model, which uses the SQL query language. DynamoDB is a NoSQL database that is built on the concept of a key-value store with capabilities to store documents such as in a document DB. So we will focus mainly on these two concepts during this tutorial. Let's figure out what kind of features key-value stores and document DBs have. A key-value store is a data storage paradigm that in its base consists of a key and a value. It is also known as a dictionary or hash table. So you can visualize it as a file with a simple table comprised of two columns, a key and a value. In order to find the value, you will simply need to specify the full key. As you can imagine, such a query is extremely fast, as only the value of the key needs to be found, and then the value can be retrieved. NoSQL databases such as Amazon DynamoDB are using the key-value store concept for their database, which allows them to guarantee high-performance reads. But usually when you work with data, you don't only have a key and a value, you might have a key and several values. For example, when you have a product and you want to have several attributes per product, such as for example the name, the price and other attributes. Maybe you also have the requirement for different kinds of formats for how you want to store the data. And this is where the concept of a document store comes into play. A document store is a data storage system designed for storing, retrieving and managing document-oriented information. A document can come in different formats, of which one of the most popular these days is the JSON format. Document stores may or may not rely on the concept of a key-value store, but in this example we will use a key-value store to visualize how the concept works in general. Let's take our key-value store example from before to see what this might look like. As you can see, the key is the same as before, but we have now a full JSON document stored as the value. This has the advantage that each document can have different kinds of attributes, and this is also called a schemaless design. In the first record, for example, we have specified a memory attribute, which we didn't specify in the other two JSON documents. If you want to find the value, as with the previous example, you will query for the full key. So the query time is as fast as with the previous key-value store example. The only difference is that there is a little more data to read, but this will hardly have an effect on latency, as long the amount of data is not very large. But you might now ask yourself, well, okay, but how would I structure relationships in a NoSQL database, and how can I narrow down the results by filtering based on additional attributes? Searching for the full key alone is insufficient. And you're absolutely right. The answer to this question is that this will differ based on which NoSQL database you'll use. And that's why we'll get further into the specifics when we look at DynamoDB itself. So what are the advantages of a key-value store database? Well, one of the advantages is that the queries are extremely fast. And another is that data can be distributed over several servers and storage nodes, as there are no traditional relationships. This enables better availability and scaling. But there are also disadvantages of using a key value store-based NoSQL database. One disadvantage is that you need to know your query patterns up front because of the way the data has to be structured. Another disadvantage is that more thinking needs to go into how the data is structured up front. And the third disadvantage is that you might need to write scripts to rearrange data if new query patterns emerge, which were not anticipated. In addition to the key value store and document store databases, there are also other NoSQL databases, such as graph databases, for example, that work with nodes and edges to form relationships. I'll however not dive into the concepts of graph databases, as DynamoDB doesn't use this concept. So, as you have seen, there are pros and cons of using traditional relational databases or NoSQL databases, and it will be up to you to figure out which is best suited for your data and use case. So, to recap, in general you would use a traditional relational database if the query patterns are unknown up front, if complex relational queries are required, if the queries need to be flexible, and if you need fixed data types for attributes. And you would use a NoSQL database if you know your query patterns up front, if the keys you want to search for are known, if your data model supports it, if high performance and low latency is required, and if horizontal scaling is required. The positive thing is that Amazon offers several databases. AWS supports relational databases through a product called Aurora, and NoSQL databases such as DynamoDB, Neptune, which is a graph database, and Elasticsearch, which is a database optimized for full-text search. This gives you the advantage that you can use a combination of databases that best support your query patterns. With this out of the way, we can now look at the specific features of Amazon DynamoDB. One of the greatest features of Amazon DynamoDB is that the database is fully managed. DynamoDB is a serverless service, which means that the infrastructure such as the servers, operating systems, security patching, cluster scaling, and other administrative tasks are handled for you in the background. You simply create tables and scale up or down as you like without any downtime or performance impact. DynamoDB comes with encryption at rest, which means that the data can be stored encrypted in the database, and in-flight encryption, which means that the data is sent to DynamoDB over an SSL encrypted connection, which helps to protect sensitive data. It provides on-demand backup for short-term, long-term, and archival purposes. DynamoDB supports point-in-time recovery, which allows you to restore a table at any point during the last 35 days. DynamoDB is spreading the data and traffic over several servers within 3 availability zones, which means 3 data centers within the same region. The data is written on SSD disks and is replicated over the 3 availability zones. This ensures high availability and durability. Additionally, AWS offers the possibility to sync tables across different regions if required. As each region is independent and isolated from the others, you will have a fully separate copy of the data. Because the data is stored and made available through several servers, DynamoDB will deal with almost any amount of data, and because it uses the concept of a key value store, the queries can be executed with constant speed regardless of the amount of data. DynamoDB also contains a fully managed in-memory cache called DynamoDB Accelerator, or DAX in short, which can reduce the read time from milliseconds to microseconds. And with this, you now know the most important features of DynamoDB, and we can jump further into the details on how to structure the data and query with DynamoDB. DynamoDB consists of tables. The records in a table are called items. Items can be retrieved by a partition key, which is equivalent to a primary key, or a combination of a partition and sort key, which is called a composite primary key. Let's first take a look at how to query with a partition key only. In this example, we will use the partition key as the primary key. Each row that consists of the partition key and attributes is called an item and equivalent to a record. The partition key is called as such because each item can be stored on a separate partition on the SSD drives and identified through the partition key. The partition key has to be unique and needs to be provided in full. Now this is fine for certain use cases where you just want to get single records, but what is if you would want to use filters to narrow down your query based on an attribute? For this you can use another key called the sort key, which we will look at next. In addition to the partition key, which is mandatory, a sort key can be added. The primary key is composed of both keys, the partition and the sort key. This is also called a composite primary key. When using a composite primary key, the partition key doesn't have to be unique per record, but the partition key together with the sort key has to be unique per record. This type of primary key gives you more flexibility to query and filter the data. In this example, we have the username as the partition key, and then we have related data specified as the sort key. If we wanted to retrieve all data for JDO, we would query only for the partition key. But if we only wanted the home address of JDO, we could further filter down on the home address using the sort key. This should now give you an idea of how relational data can be modeled within DynamoDB. The sort keys called userinfo, home address and business address are all related to the same user JDO. And as JDO is the partition key, all the data for userinfo, home address and business address will be stored on the same partition and can be therefore accessed more quickly. The sort key does support query conditions which include equal to, less than or equal to, less than, greater than or equal to, greater than, between and begins with. So if we, for example, have a list with articles from different authors and we would want to query for the newest articles, we could use a query that has the author as the partition key and the date as the sort key. This way we can query for the articles that were created after the 20th of Jan 2022, for example, by using the greater than option and would then only get back the first two results. So I hope with this you now start to understand how you can structure relationships and query filters. But what is if we would want to query both for articles by author and articles by category? Currently the category is only an attribute in the document and we can't query for it directly. And this is where secondary indexes come into the picture. So what the heck are secondary indexes, you ask? Secondary indexes can be used to query for the data with alternate keys. This means you can project other attributes stored in your JSON document onto the partition key and the sort key. DynamoDB supports two kinds of indexes. It supports local secondary indexes, also called LSIs, and global secondary indexes, also called GSIs. One point to note when using secondary indexes is that your schema will not be that schemaless anymore, as in order to create secondary indexes, the attributes you want to use to query in the documents will have to be called the same. Let's have a look at local secondary indexes first. A local secondary index can be used to do queries for items with the same partition key, but a different sort key. So you can define additional alternative attributes that you have in your JSON document, which you can use as the sort key. A local secondary index must be created at the time the table is created, as the index will reside within the same table. And once created, it can't be added, modified or removed any longer. You can only create up to 5 local secondary indexes per table as per the documentation. But what is if you wanted to change both the partition key and the sort key? For example, let's assume we want to find customer records by country and narrow them down by zip code. For this, we can create a global secondary index that uses the country and the partition key and the zip code as the sort key. Global secondary indexes are basically copies of the original table, but with a different partition and sort key. The data is synced from the main table to the secondary tables. You can create up to 20 global secondary indexes. GSIs can be added and deleted at any time, but as more writes are required, the costs will be a little bit higher. And this is more or less it. With this knowledge, we can now move from the theory to practical examples. I hope this tutorial was valuable and gave you a good overview of what DynamoDB is, how it works and how to structure the data and how queries work. If you enjoyed the video, I'd appreciate if you could give it a like and consider subscribing if you wish to see more content like this. Have a good one and see you in the next video.